Today we're going to be looking at the PT-181 Building Automation Training Simulator. It's a very robust unit, so let's get into it. The unit comes shipped in a very robust case. It's got these really heavy-duty latches, so if we open it up we can see inside. And I'm going to take off the ends so I can pull off the front cover. So it is really cool that these pins just slide out, and this way you can pull the front off. And there we have it. One great fact is that it's portable. You can bring this out in the field, you can train some of your workers, you can bring it to different offices. It's got a lot of different options because it's portable and it's not, drilled and screwed to a wall. iConnect Training's PT-181 is a portable training unit specifically designed for the DDC industry, with direct digital controls. It's packaged with a curriculum that is embedded in the JACE controller, and it's also included in a printed workbook and on a USB flash drive. Now, I've taken the course on my own, self-paced, and it was just as effective. This unit incorporates some of the most popular DDC devices currently in use in the industry. Who can benefit from the PT-181? This can include HVAC technicians, whether it's service, repair, or install, building automation system installers or programmers, IT professionals, security experts, companies testing DDC devices or systems, and really any technical trades. The PT-181 and the JACE controller can be utilized in building automation systems, home automation systems, commercial processes, security, lighting, metering, and also HVAC applications. On the last slide I mentioned security and IT professionals. You may have heard in the news about buildings being compromised or systems being compromised through the building automation system. Hackers or people targeting systems are trying to get through the building automation system to get onto the building server. So companies are buying training simulators like this and trying to hack in themselves or seeing what the security features, functions, and options are. Save you a lot of time and effort right now. Please change the username and password from admin. So the PT-181 is using the Niagara framework. This is great because you can really build off the infrastructure. On the bottom of the slide, you can see the different features that Niagara is capable of doing. This unit is really focused on the building aspect. So this includes thermostat, HVAC, temperature, etc. You can also control and monitor energy, whether it's lighting, metering, temperature. You can get into Niagara security, which is intrusion detection, card access, etc. And then Niagara video, which is CCTV, DVR, IP video. You can see with all these different features and functions, this system can be really robust, and you want to make sure that the security is very tight on it. So some of the specifications of the PT-181. My estimate was a little bit off. The shipping weight is 44 pounds. And you can see the dimensions there, 24 inches by 21 inches by 10 inch depth. Some of the features of the PT-181. You can see it includes the JACE 8000. It has BACnet, LAN, and Modbus licenses, which are permanent. You're not having to renew these every year. It has a 34-point remote input-output module. Some of the other devices that it talks about we'll get into on the next slide. So as you can see, the unit is identical to what you see in the picture. Number one, the JACE 8000 controller. Some people consider it the brains or the central nervous system of the trainer. So JACE 8000 was developed by Tritium, and it's using the Niagara N4 framework. In the controller, there's a microprocessor, a web server, and several network ports. The I/O module has 10 digital inputs, 8 analog outputs, and 16 configurable universal inputs. You can see here the Ethernet switch has 5 ports. Number 7 here is this orange device. It's the Belimo actuator. And so this motor would allow you to open and close dampers. Number 8, the VFD, variable frequency drive. This will be used to control the speed of a motor. And then there's various different switches and push buttons and displays that are utilized with the training simulator. The last thing I wanted to point out from this slide, number 10, this is the RTU, the rooftop unit controller. And so this would be a thermostat that you would see inside of a building, maybe a little bit more advanced with a touchscreen display. So in this slide you have 11 through 21. Number 11 here, the FCU thermostat. So this is a fan coil unit thermostat. Number 12 here is the IAQ, indoor air quality and CO2 sensor. So I wanted to dive a little bit into the lessons. We're not going to get deep into them, but just to give you an overview of what's included with the workbook. Lesson 1 starts to get you familiar with electricity, definitions, DDC terms, and really just familiarization with the training simulator. Lesson 2 starts to get an overview of HVAC equipment and applications. So this includes basic needs, temperature, humidity, air quality, energy savings. Lesson 3 starts to get a little bit deeper into the DDC devices and components. It dives into input, output, and logic. Lesson 4, you start to talk about communication. And this is BACnet, LAN, Modbus, and some other ones. And then about the transmission, hardwired versus wireless, past and future. Lesson 5 dives into the controller. So we're using a JACE 8000, but it gets into the background, the Niagara framework, a closer look, and then the PC to JACE interface. Talks about platforms and stations as well. Lesson 6, you heard the word station. So lesson 6 dives a little bit deeper into that and gets a closer look at a station. Lesson 7 gets into the programming fundamentals. This is where you're going to start working with Workbench. You're going to work with sequence of operations, logic flow, programming methodologies, get into control palettes, and then digital and analog programs. Lesson number 8 gets into a sampling of basic DDC programs. So a motor stop-start, and then some other control programs. Lesson number 9, understanding the BMS, Building Management System. It gets into some of the deeper details of the BMS. Schedules, alarms, trends. Number 10 gets into troubleshooting the DDC systems. This is great because if you're out in the field, you're going to run across this stuff. Lesson 11 dives a little bit deeper into the actual unit devices, so fan coil with DX cooling and electric heat. You'll be learning about a sequence of operation into a program for that unit. Lesson 12 is an overview of HVAC and DDC control manufacturers. This is great because you dive into open and proprietary systems, the major players, and keeping up with the Joneses, staying informed. Lesson 13 starts to dive into your career, your employer expectations. So the flexibility, the job descriptions, the keys to success. And then if you're a trainer or a student, you can do a final exam. This would kind of wrap all the information that we learned into this exam. This slide is something that I put together to show you the information that you're going to learn throughout the curriculum. So in the lesson, Programming Fundamentals, you dive pretty deep into the terms, the different types of points, and the objects. If you're familiar with DDC points, you have Boolean, enumerated, numeric, and point strings. When you get into Workbench, those will be identified by different colors, as you can see here. The lesson dives into the different objects, whether it's logic, math, or HVAC. Then it also talks about read-only versus writable points. Throughout the curriculum, you'll be connecting the JACE controller and the unit to a PC. On this slide, you can see step-by-step directions how to connect to the PC. You also learn how to connect through Java or through the HTML web browser. So I've booted up the unit, plugged it in, gave it a few minutes, and now it's ready to connect. To connect to the PC, I could either plug straight into the JACE or into the network switch. Since the network switch is there, I'm going to plug into that, and this allows me to do some different features throughout the curriculum. So once we're plugged into the JACE, we can pull up our IP address for our particular unit. We can log into our unit. We need to make sure the password's typed in correctly. And now you can see the software embedded on the controller. So if you were doing customized programming, this could be your summary page. This could be your building information page. It could have the temperature of each room. You could have different screens here. So you can see the course outline, the lab exercises, the trend log data, alarm console, wiring diagram, and HVAC examples. If we click on lab exercises, we can see the 4 different labs. Lab 1 starts to get into the actual devices. And there's just a lot of good information throughout the software. Lab 2 starts to get into the wire sheet, wiring schematics, flow diagrams. Lab 3, we get into the programs that we had talked about: motor stop start, thermostat program, PID loop program, math and logic program. So to give you an idea, here's a PID loop program. And so this would be the wire sheet, and you would actually drag these components and then link them together. To show you a simplified version, here's a motor stop start. And again, so you might be thinking, that's great, but I'm not going to have a motor stop start and I'm going to be more advanced than that. Is it worth it? So Lab 4, this is a program that you would actually utilize, a fan-coil program wire sheet. And now you can see this is a full-on program for a fan-coil unit. You can see all the different components, all the different links, and how they're all tied in together. So the curriculum will take you through this. It'll explain it. It'll dive deeper, and you'll come out of this really having a good understanding of how it all works. Another great option in this program is the HVAC examples. So you can see all the different types that you might run across in the field. If we click on AHU, air handler unit, you can see the graphic here. So this would be a graphic that you might run across in the field. It might look a little different. It might be 2D versus 3D. It might have some rotating fans. And then you'll learn about the nav tree. So if I click this, you can see the nav tree, the services, the drivers, the logic, different places for files. You can see here the PT-181's wiring schematic. You'll learn about the palette, so you can see the different options here. You'll learn about the different kits. So you can see through the lessons and the lab exercises, this will really start to get you comfortable with the different devices, programming the different devices, linking them together, all through the JACE, the brain, the controller. So now I want to take you through a few different videos of different times that I connected to the unit and to show you some of the different features. And so next we're going to look at the CO2 indoor air quality sensor. So looking at the parts per million, we're at 555, and on the computer showing 557. And so based on what we talked about, what's acceptable? Really, anything under 1200, ideally I think we're in the 400 to 600 range, but anything under 1200 is going to be fine. So let's see what happens when I breathe on this. You can see it climbs pretty steadily. On the computer screen we just hit 900, 1000, 1400, 1500, 1900, 2000. And basically this unit's going to cap out at 2000. That's the max level. And so what would we do to bring this parts per million down? Really the best way is ventilation or outside air. Those are the only two ways to bring that parts per million down. We need to bring in new, fresh air. Okay, so moving on to the VFD, we're going to turn it on. And so imagine this VFD is tied to a supply air fan motor. The desired duct pressure should be maintained at 1-inch water column, WC. So for the controller and duct pressure drops, what would we have to do to the VFD? We'd have to increase the speed, right? You can see frequency output's rising up, the speed signal input's rising up. We overshot it. What do you have to do? Obviously decrease it. To decrease it, you can see it drops down. What kind of control action did we just simulate? That'd be a PID. Okay, so now we're going to look at the actuator, the Belimo actuator, and you probably can't read it, but what kind of output does this controller require? And on the cover, it has output 2 to 10 volts. And so on the computer here, we can see signal reference input 2 volt, position feedback 0%. You can see that we're at 2.02 volts. Now if we bring this up to 50%, you see that climb to 5.62. And on the computer screen, we got 5.7. You can see the position feedback starting to rise up. And eventually that'll get to 50%. It's a little bit slow. The actuator doesn't, jerk open and close super fast. If we brought it all the way up to 100%, we're at 10.1 volt. On the computer screen, we got 10 volt. And then that position feedback would climb all the way to 100%. So what are some of the devices we would control this with this actuator? And that would be air dampers, water valves, steam valves. Key terms, we're going to dig into those on the next slide, as usual. But there's 3 elements that are absolutely essential to any DDC operation: input, output, and logic. So input, what do we need to know? Output, what do we want to do with what we know? And then the logic, how do we do it all? So the basic example on the bottom here, operation, we need to heat a room to 72 degrees. Input, what we need to know, or how we need to know, is temperature sensor. Output, what to do, electric heater, for example. I don't promote electric heaters, but good example. And logic, how do we do it? And so that's with the thermostat or controller. Okay, so we're going to look at the input-output module. If you remember, this had 16 inputs. And so here you can see all the different inputs and outputs. One cool thing, and you get into this a little bit further on in some of the lessons, but Niagara has these color codes. So green is Boolean, purple is numeric. We don't have any orange on here, and I don't see any gray. But it's pretty cool to know that they got some color coding things for some of the Niagara objects, and so it makes it helpful when you're digging in a little bit deeper and you need to try to find something. So back to our lesson, the first thing we're going to look at is digital input 1, this PB switch. So we can see here it's a Boolean input. The conversion is default, the read value is false. And we're just looking at a few different things, trying to see, what input outputs look like in the computer. So now if we look at an analog input, this 10K pot, we have a resistive input, conversion is default, and then the read value here is, let's say, 10 ohms. And now if we adjust this dial here, you're going to see it shoot up. Right, you see the ohms there shoot up. So we'll bring that back down to 0. So that's one of the analog inputs. So the next analog input that we're going to look at is the actuator position. And so this is a voltage input, conversion's default. Current read value is 2 volts. So if you remember On this orange actuator, this is a 2 to 10 volt system, and so I'm going to adjust it to open it up, and we'll see what the voltage does. So I brought it to 20%, and you can see this read value starts to go up fairly quickly. At 20%, I'm guessing it's going to be somewhere in the 3 to 4 volt. So there it stopped, 3.6 volts. So now looking at some of the digital outputs. Digital output 1, this green light, that I want to show you an actual example. This would be a makeup air unit inside of a pool HVAC control system. So you can see there's a lot of different functions and features on this. And so, you know, all of those analog, digital inputs and outputs, they're all feeding into stuff like this. This would be a graphic that would be at the customer site. This is a pretty advanced one, but you know, all facilities are going to have graphics like this. You can see there's 50% open, there's temperatures, there's percentages, there's relative humidity. You know, what percentage does this need to be opened or closed? If it needs to be cooled, if it needs to be heated. You know, if this parts per million gets too high, what are we going to do? And so that's what the controller is doing. It's taking all of these inputs and outputs, and based on what the programmer or the integrator designed it to be, it's going to do all this stuff automatically, unless the user goes in and overrides it, of course. But digital and analog inputs and outputs are very important. They're the backbone of a BAS system. Now we're going to open the navigation tree. If we look at this config file, we expand that, we expand the drivers file or folder, we can see the different networks that this is using to communicate. So Niagara, N-I-R-O, I think you pronounce that Rio, and then BACnet. So we talked about BACnet, right? Now if we expand the BACnet, see on the bottom here that it's communicating with two devices, the rooftop unit controller and then the fan coil unit controller. So if we expand the fan coil unit controller and we look at the points here, you can see these are all the points that are communicating back and forth between the JACE. And so now if you look at the fan coil unit here, we got all the information that's displaying on the screen here is displaying on the computer. What I'm going to do here is I'm going to raise this temperature up. So we'll go to 79 degrees. On the computer, it should kick into heating, and we should see the heating demand go up. It may take a little bit here. So there you can see the heating demand jumped up to 100%. It needs to do it ASAP. Now if I bring this down, let's say the room started to heat up and it got down to 76.5, we should see this heating demand start to taper down. So there you can see it's 63%, and it may stay there for a little bit, and as we got closer and closer to our set point, it would continue to drop 14%, and so forth. And so likewise, if we brought this temperature down, we're going to see the cooling switch over, and we'll see some of the changes that display on the computer. So you can see the swap over, heating went 0, cooling went 37%. Now it would run until it started to cool the room, would get feedback from the thermostat or the set points or the room temperatures, and you know, it would use its algorithm, its smart controller brain, and change that demand for cooling. So we're going to collapse the fan coil unit and open up the rooftop. Most programmers out in the field are going to use Workbench, but they do have the option to utilize either or. So some of the things that you can do inside the controller, right? Some of the services are chores, right? When you're controlling the alarm, the history, the emails, the backup, the platform services, And then you get into drivers, right? Depending on what you're using. So the logic. This is the programmer's canvas. So you can see it's another picture of the wire sheet. This starts to dive into the wire sheet a little bit more. So Niagara N4 is an object-oriented programming method. The occupied heat set point, right? At 70 degrees. This is a physical and virtual point that can be adjusted locally at the device, right? We can adjust it here, or we can adjust it or command it written by the JACE, allowing the set point to be adjusted remotely. So in the logic folder here, this is where most of the application operations are carried out. So you can see the different subfolders, right? If we go into default setup, here's our wire sheet we talked about. And so if you're looking at here, you can see the output. This will feed into the input. That's true. There's an output here, it feeds into the VFD hertz. So as I move this sensor up and down, it's going to change on the wire sheet. Right, so the slide output is going down, this is feeding in here, and then it's feeding out to the hertz, right? So we're at 5.1 hertz. As I bring this up, I jumped up to 12 hertz based on the output here and based on the output here, right? So it's pretty cool to see it live time. If I jack it all the way up, 3.4 volts, 3.4 volts out, 20 hertz. If I bring it all the way down, 0 volts, 0 hertz. Next thing I want to look at is the files folder. And looking at a sequence of operation, right? Here we have a basic sequence of operation, right? The heating set point is at 70. If it drops below 69, we're going to turn the digital output 1 on. If it rises above 71, the digital output 1 turns off. And so input number 1 is the room temperature. Input number 2 is the set point. The logic is the heating thermostat. And the output is digital output 1, right? So to give you a quick overview, again, this is the IO34 module. This is where the HVAC logic is residing. And so what inputs on the computer is this feeding to? Room temperature, analog input 8. The output, 73.2, is feeding into the logic. Here you can see. And then that's feeding out to digital output. Heat element, digital output 4. So you can see our set point is 76 degrees. And this is feeding into the set point. The differential, looking at 3 degrees difference. And the action, what is it going to do? So you can start to understand how the object methodology works. You can see over here, this is the large overview, and then if we scroll down, we can see some of the different programming. We're going to open a palette. We go kick control. So here you can see we just opened a whole palette. We're going to expand control palette, and then we're going to expand points. So here's all our different points. Now let's go back out and go to the logic. So you can see the logic folder. We have and, equal, greater than, less than, right? And is only when all inputs are true, or input that is true will cause output to be true. Close that. Look at the math. Basic math, right? The average, the maximum. You might use different math functions. Close that. We can look at the HVAC. So you can have some different objects, right? T-stat. We all know what the T-stat is. So double click that. You're going to see a typical T-stat object. So that's it, a quick overview of the PT-181. This building automation training simulator is a very good tool to have. It incorporates the JACE 8000, which you're going to see throughout the industry. A lot of manufacturers are utilizing it, just to name a few: Honeywell, Distech, JCI, Allerton, Vicon. They are all using some form of the JACE 8000, and so if you can learn that controller, you're going to be well off in the HVAC industry. This unit can be used in a classroom setup with a dozen different users, or it could be used, as I said, in a self-paced learning environment. The PT-181 is very versatile. You can train multiple people with multiple units, or you can train individuals with a single portable unit. They can be linked together. The trainer-student atmosphere can be as deep as you want it to go. The one thing I love about it is it's basically a building in a box, right? You're going to have all these different components throughout the building. Instead of running around to test and touch each one, you have it all in one unit. So you can really learn the programming, the system, all in one sitting. If the PT-181 is a little too advanced or extreme, iConnect Training also has a few other different training simulators: the BL01, the BL02, and the PT-201. Each of these units has unique features and functions, so depending on what you're looking to get, you can also check those out. As we talked about in this slide, a lot of different people can benefit from the PT-181. That wraps up this video on the PT-181. Hopefully you learned a lot about what it is, what it entails, and a little about the curriculum. In the future, iConnect Training is looking to release a second edition of the curriculum, a level 2. This will dive a lot deeper than the level 1 curriculum. Definitely check out iConnect Training's website for the PT-181 as well as several other building automation training simulators. Thanks for watching, everyone.